Hi guys, today I'll be talking about Trace Creek in Ohio. I'm using Trace Creek as my sample creek to study the NRCS stream classification methods, which is also known as the rosgen classification method. And I'm also going to be doing a BEHI assessment on this. So this is Trace Creek right here. It's part of the Goan watershed. It starts in Scottstown and travels along Route 775, and it's roughly about 3 miles. I would say it's not a really big creek. It's about 3 miles, and the picture on the right is again a topographic map of the same creek. You can see how we have Trace Creek as well as Big Spring Creek and Wall Creek and several other creeks because this is all part of the Goan watershed. So the one on the left is a view of Trace Creek upstream, and the one on the right is the view of the creek downstream. As you can see, the majority of bed cover is basically small-sized boulders and dry leaves. The leaves is obviously seasonal. I have taken pictures of this creek during fall when it was shedding, so we have a lot of leaf that's covering the top of the creek. The six main components that we look at when we're doing the stream classification according to Rosgen is entrenchment. Entrenchment is basically looking at how accessible the floodplain is to its stream. This is given by flood-prone width of the valley over the bankful width of the street of the channel. My value that I got is 0.9953, and I'm going to take an approximation of this and make it 1. The second component that we look at is the width to depth ratio. From the pictures that I just showed you, this is the estimation that I have got. It's around 26.67 feet. The third component is sinuosity. That's basically looking at the curvature of a stream. Every natural stream is going to have curves. It's never going to be a straight stream. So sinuosity is basically given by the stream length over valley length. And in my case, I have got 1.1125. I've just used like a basic Google image, Google Earth image for this. And then we have the number of channels. It can be either a braided stream or a single stream. Basically, if you have multiple streams in it, it's going to be a braided one, and mine is a single stream. It doesn't have a lot of deviations in it, so it's a single stream. And another thing we'll be looking at is the slope of the entire stream, and sometimes this can be kind of equivalent to the sinuosity. And then the final component that we'll observe is the bed material. Um, like I already mentioned, in my case, it's mostly boulders and leaves, dry leaves. So here I have a method of actually measuring a stream. The first picture on the left on top is actually telling us what a bankfull stage is going to be and what you're looking at in terms of the floodplain and things like that. Here they are using the surveyor's rod and a level to actually take down the measurements. I didn't have any of that, so I just used regular measuring tape. And then on the bottom we have a view of the stream types in giving the cross section of it. Um, you're basically trying to figure this out from the slope that we just obtained. Mine is roughly around less than 2%, which falls under the F type of stream. And then on the right hand side is what we've been talking about this whole time, the six components that we looked at. The Roskin's classification of natural rivers. The first one is the entrenchment ratio. If you can remember, mine is 0.9953 and I took an approximation of 1. So it falls under the entrenched category, which is a ratio less than 1.4. And then the second one is the width over depth ratio, and mine is at 26.67. So under for the entrenched, anything greater than 12 would be moderate to a high width to depth ratio. And then we have the next component as sinuosity, minus 1.1125, which is just less than 1.2. But since this doesn't have an option, I'm just going to take it with this. And it gives me the F type of stream. And when we actually look at the bed material, I mentioned it's basically looking at a lot of boulders. Of course, the boulder size is going to vary. It's not really big, but it is small sized boulders, which is the major component of my stream. So I would say mine falls under the F type of stream. This is another picture showing us the bed material. You can see it's just pebbles and leaves, and the other component here is a little bit of mud, I would say. And this is what the bed material is in my stream. So this is the worksheet that I filled out for my creek. So every time you do this, you have to always enter the name of the valuator, the date, and the place that it was carried out, along with the latitude and longitude of the place. And here we have the width and depth ratio and the sinuosity. In my case, I just used the length aspect of it and not the slope. And also my creek is not really that big, and we generally have to take like 2 meander lengths of the creek. That's basically like 100 feet with some curvature in it. But because mine wasn't that big, I just used a smaller piece of the creek to my measurements. And then I have my entrenchment ratio here, which is around 1, like we already saw. And then the dominant channel, which is basically small sized cobble. And also the organic matter is all the dead leaves that we've already seen. And another thing that we will be noticing here is the description of soil. In mine, I would say it's basically just sand and mud. And another component that we will be studying in the classification method is the riparian vegetation. So from the pictures that I've already shown you, the left bank doesn't really exist. It has a street that runs along the whole length of the left bank. Um, so it doesn't have a whole lot of vegetation there. It's just around 30 to 40% coverage. And then the right bank is pretty decent. It's not densely populated, but it still has like a 60 to 80% coverage, I would say. And here we are looking at the root length and the height, and these are the values that I got for my measurements. And here is the slope that I calculated. The left bank slope is around 10 degrees and the right bank slope is around 20 degrees. And like I've already mentioned, mine is an F type stream, and we already saw it's a single braided single stream, single channel stream, and it is an alluvial stream with 20% riffles and 80% pools in it. The second half of this is looking at the pebble count. Here is the reference that we use to look at the size of the pebbles and boulders and everything and try and categorize them. Um, right side is the Excel sheet that I use to fill out the number of rocks, boulders, pebbles, and everything that I have. And this is the total that I have that I got. Sand is around 15, fine gravel doesn't exist. Coarse gravel is around 60, cobble is 14, and boulders at 10. So it's basically looking at the whole stream and saying that it is in a pretty good condition, and this is what we get from mine. Next, we'll be looking at the BEHI method. This is again a Rosgen's method. Um, it stands for Bank Erosion Hazard Index. So every time every stream is prone to erosion, this can be man-made or a natural cause. Of course, because of man-made causes, the percentage of erosion is going to increase. This can be due to urbanization or building dams and things like that. It will actually increase the chances of erosion. And basically, we would want erosion to take place to a certain extent. So it actually lets some sediments pass through the stream. But if excess of this happens, then it's not going to actually flow through wherever we want it to go. It's just going to be stagnant, and there's no point in that. Um, so this is what we'll be looking at in the Beehive method. There's actually two versions of this. There's the main method and the modified method. I'm just using the main method. It basically has 5 metrics that we'll be looking at in order to get the BEHI score on this. So the complete method is something like this. This is the chart that we use. So for every value that you get, there's a BEHI score related to that. The 5 components that we'll be looking at is the bank height and the bank full height, root depth over bank height, the root density, which is measured in percentage, surface protection, again measured in percentage, and the bank angle. Now, depending on the value that you get in the previous step, you'll be categorizing that as a very low, low, moderate, high, or very high, and extreme BEHI index. Let's just look at the values that I got for Trace Creek. The first picture is of um, the right bank. You can see how it is pretty well populated with trees. It obviously doesn't have a full coverage. I would say somewhere around 60 to 65% coverage. And then the left bank here, you can see how there's a street running across the whole length of this creek on the left side, and this is the vegetation coverage that we have here, and you can see how the roots are kind of exposed. And then the picture on the bottom right corner is a picture of how the roots are extremely exposed, and this is pretty much how it was on the left side of the bank throughout the length of the stream. So for the left bank, I got a value of for the bank height over bank full height, I've got 2 feet. Root depth over bank height is at 60%. Root density is 5 to 14% for my left bank. You can see it doesn't have a whole lot. And then the surface protection is 10 to 14% because it doesn't really have a whole lot of vegetation to cover the land with trees. That's basically trying to protect the soil from eroding. And then the bank angle is between 81 to 90. It's pretty steep. And then we have the values for the right bank. The bank height over bank full height is 10 feet. Root depth over bank height is 10%. Root density is between 30 and 54%. The surface protection is almost the same, which is 10 to 14%, and the bank angle is extremely steep, so it's greater than 119 degrees. And one thing we have to see here is generally there's a BEHI value that you get for both the banks together, but I felt the need to separate mine as left and right bank because it had varying values, so that's why I did like a separate left and right bank BEHI score. So this is the value that I got for mine. As you can see, according to whatever values that we just got, these are scores that's in sync with the values, and we're basically adding up everything and ending up with a value of 32 for the left bank, and the same is done for the right bank. And it's not a huge variation, but when you look at the individual values, there is slight variations, and so that's why I took it as a different component. And then the right bank ends up having a value of 37. So both of them come under the high erosion category, which is between 30 and 39.5, and that's the BEHI score for Trace Creek. And here are my references. Thank you.